Welcome! In this lesson, we'll solve a classic bond amortization question, and then, as a quick bonus, we'll practice molecular polarity with VSEP, our shapes. Let's start with the accounting problem. A corporation issues $200,000, 10%, 5-year bonds on January 1st, 2017 for $191,600. Interest is paid semi-annually on January 1st and July 1st. Using the straight line method, what is the bond interest expense on July 1st, 2017? Here is our problem statement. We'll highlight the key data, then compute discount, number of periods, amortization per period, cash interest, and finally the interest expense for the first period, July 1st, 2017. Step 1. Compute the total bond discount. That's face value minus issue price, which equals $8,400. Step 2. Determine the number of interest periods. 5 years with semi-annual payments gives 10 total periods. Step 3. Straight line amortization per period is the discount divided by the number of periods. 8,400 divided by 10 equals $840 each period. Step 4. The cash interest payment each period comes from the coupon rate. 10% of $200,000 per year, split in half for semi-annual, gives $10,000 every period. Step 5. The interest expense under the straight line method equals cash interest plus discount amortization. That is $10,000 plus $840, which equals $10,840. Looking at the choices, the correct answer is choice C, $10,840. A quick intuition check. Because the bonds were issued at a discount, the carrying value increases by $840 each period as we amortize the discount. That is consistent with our straight line result. Bonus practice, molecular polarity. Which of the following is polar? CCl4, XeF2, XeF4, PBr5, or BrF5. We'll sketch their shapes, look at symmetry, and see whether bond dipoles cancel. Here are quick VSEP, our sketches. Tetrahedral CCl4, linear XeF2, square planar XeF4, trigonal bipyramidal PBr5, and square pyramidal BrF5. Notice the symmetry of the first four. For CCl4, the 4 bond dipoles are symmetrically placed and cancel to 0. Nonpolar. For XeF2, 2 opposite bonds cancel. Nonpolar. For XeF4, the square planar bonds cancel in the plane. Nonpolar. For PBr5, the trigonal bipyramidal symmetry cancels dipoles. Nonpolar. But for BrF5, the shape is square pyramidal, and the bond dipoles do not perfectly cancel. This makes the molecule polar. Final results. The bond interest expense on July 1st, 2017 is $10,840, choice C. For polarity, the only polar molecule here is BrF5. Symmetry cancels the bond dipoles for the others.